All right, so here we're in 10.3 on derivatives of products and quotients. And so we're going to learn about the derivatives of products as well as the derivatives of quotients. All right, so if we use the definition of the derivative and the four-step process, we can actually show that the derivative of the product of two functions is the first function times the derivative of the second, plus the second function times the derivative of the first. Now, the product rule is expressed more complexly here in Theorem 1, and it's labeled as the product rule. And it's kind of made nicely so you can remember memorization. So F is going to be for first, and S is going to be for second. So that's not how it usually is done, but that's the way it's done in our book. And so Theorem 1 says for the product rule, if y is equal to f of x is equal to some first function times some second function, and f prime of x and s prime of x exist, so the derivatives both exist, then the derivative of the whole thing is going to be the first function times the derivative of the second, plus the second times the derivative of the first. Now, if we use other types of notation, we can use y prime is equal to f times s prime plus s times f prime, or dy dx is equal to f times ds dx plus s times df dx. And so this is derivative of s with respect to x, which is s prime, and this is the derivative of f with respect to x, and that's our f prime. Okay, so we want to use two different methods to find the derivative for the function f of x equals 3x cubed times 2x squared minus 3x plus 1. All right, so first things first, let's do the easy way. Well, first off, the easy way is going to be simply multiplying this out first. So we'll take 3 times 2, we'll get 6, and x times that, we'll get x to the 5th, and then we'll have a minus 9x to the 4th, and then plus a 3x cubed. So we can find that derivative very easily. F prime of x is equal to what? Well, 5 times 6, so that's going to be a 30x to the 4th. And then minus 4 times 9 is going to be 36x to the 3rd. And then 3 times 3 is going to be 9x squared. Again, we're just decreasing each of the powers by 1. And so, as you can see, that was pretty quick. So now let's do it the other way, where we're going to use the product of the two. And so again, what we're going to do is we're going to take, to find the derivative, f prime of x, we're going to say, well, we're first times the derivative of the second plus the second times the derivative of the first. So then in that case, that's going to be 3x cubed times the derivative of this, which will be a 4x minus 3. So just bring the 2 down times that, subtract 1, and then just drop the x. And then we have plus. Now the second, which was our 2x squared minus 3x plus 1, times the derivative of this, which can be 9x squared. And now guess what? We have to multiply and get it simplified. So 3 times 4 is 12x to the 4th minus 9x to the 3rd, plus now we have here 18x to the 4th. Then we have minus 27x to the 3rd plus 9x squared. Now we've got a 12 and an 18 on the 4th, so that's going to be what, a 30x to the 4th. Then we have an x cubed and an x cubed, so that's going to be what, minus 36x to the 3rd, and then plus 9x squared. And as you notice, that is equal to that. Now, which one was easier? Well, when you multiplied it out, it was easier. But what's going to happen is sometimes you can't really multiply it and make it simpler like we did here. And so really using this first times the derivative of the second plus the second times the derivative of the first really is going to help us out. So let's pause there and we'll come back for more.